All right, absolute value equations. So we're going to start with this first part. What is absolute value? So absolute value is the distance a number is away from zero on the number line. So I need you to write the distance a number is away from zero on the number line. Now, for example, the absolute value of 4. So if I start at 0, how many spaces do I have to go to get to 4? Well, I'm going to go 1, 2, 3, 4. So the absolute value of 4 is 4. What is the absolute value of negative 4? Well, again, I'm going to start at 0, and I have to go 1, 2, 3, 4. Meaning the absolute value of negative 4 is also 4. That should have been pretty easy for you guys. An absolute value equation, now, is an equation that contains an absolute value. An equation that contains an absolute value. For example, we can say that we want to solve the absolute value of x equals 9. So we've got to think about the number line here. We want to know what values of x are 9 spaces away from 0 on the number line. Well, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9 in the positive direction. Or I can go 1, 2, 3, 4, 5, 6, 7, 8, 9 in the negative direction. This would mean that x could equal positive 9 or x could equal negative 9. So these both are my solutions to the absolute value equation. Now if I plug these back in, the absolute value of 9 is 9. The absolute value of negative 9 is also 9. I need you to flip over to solve absolute value equations, and we're going to do some more examples. So example 1, we want to solve the absolute value of x plus 4 so that it equals 3. We know that this 3 is the number of spaces away from 0. So we're going to split this up into two equations because really x plus 4 can equal negative 3, or x plus 4 can equal positive 3. If this whole thing on the inside equals a negative 3 or a positive 3, the absolute value will result in the answer of 3. So we have to solve two different equations. So how do I get x by itself? I subtract 4 from both sides, and I get x equals negative 7. Or I'm going to subtract 4 from both sides of this equation, and I get x equals negative 1. So if I plug in a negative 7 for x, negative 7 plus 4 is negative 3. The absolute value of negative 3 is positive 3. If I plug in a negative 1, negative 1 plus 4 is positive 3. The absolute value of positive 3 is also 3. So both of these are a solution. You should be getting two solutions for each example. Now, this one. Solve 3 times the absolute value of 13 minus 2x equals 15. In order to solve an absolute value equation, we need to have the absolute value bars all by themselves. So that we have to move this 3 out of the way before we can separate it into two equations. So that 3 is multiplying to the absolute value. So the opposite of multiplication is division. We're going to divide both sides by 3. 3 divided by 3 is 1, and we're left with the absolute value of 13 minus 2x equals 5. Now remember, the inside of here has to be either a positive 5 or a negative 5. So that's going to give me my two equations. And when I write my next equations, I can get rid of the absolute value bars. I'm going to bust the absolute value out of jail by splitting it into two equations. One where it equals negative 5, and one where it equals positive 5. And then it's just a simple equation that we need to solve. We're going to do addition and subtraction first. So I'm going to subtract 13 from both sides. Negative 2x equals negative 18. I'm then going to divide both sides by negative 2. Negative 2 divided by negative 2 is 1. Negative 18 divided by negative 2 is positive 9. I still have another option. I'm going to solve the second equation. I'm going to subtract 13 from both sides. 13 minus 13 is 0. I'm left with negative 2x. 5 minus 13 is negative 8. Now, negative 2 times x, the opposite of that is divide. So I'm going to divide both sides by negative 2. Negative 2 divided by negative 2 is 1. Negative 8 divided by negative 2 is positive 4. So if I were to plug in either one of those x values, this equation up top would be true. So here is our two solutions. Example number 3. Now you've got a few more steps in order to get the absolute value bars all alone. Remember, we cannot do anything until that part is by itself on one side. So I'm going to start by doing addition and subtraction. I'm going to add 7 to both sides. So I'm left with 3 times the absolute value of 4x plus 2 is equal to 11 plus 7 is 18. Now I can get rid of multiplying by 3 by dividing 3 from both sides. And I get the absolute value of 4x plus 2 equals 6. Now that I've got this part by itself, I can split it into two equations. Remember, the inside of this has to equal 6. So this inside can be negative 6 or positive 6. So I could have 4x plus 2 equals negative 6, or 4x plus 2 equals positive 6. If I subtract 2 from both sides, I get 4x equals negative 8. I then divide both sides by 4, and I'm left with x equals negative 2. Or we still have one more. I subtract 2 from both sides. 4x equals 4. Divide both sides by 4. X equals 1. So my two options are x equals negative 2 or x equals positive 1. Now we do have a special case when we're solving absolute value equations. So let's go ahead and try to solve this one. Absolute value of 3x plus 5 is what we are trying to get by itself. Plus 6 equals negative 2. So the first thing I need to do is move this 6. I'm going to subtract 6 from both sides. The absolute value of 3x plus 5 is equal to negative 8. Does anyone see something wrong with this? Can an absolute value ever equal a negative number? Hopefully you said no. In this case, the absolute value of a quantity cannot equal a negative, so you can stop here. Right now, we can just go ahead and write no solution. Nothing on the inside of here will ever make the absolute value of it equal a negative 8. So the special case is when we have no solution. All right. Tomorrow, I will go ahead and show you what this means graphically. If there's some extra time in class, I'd like you to get the worksheet on solving absolute value equations from the front and start trying out some of those problems. I'll see you tomorrow.